friends, welcome to our channel Jayadithya Math Tutorial. We are doing a series of 10th class mathematics. As a part of this, we are now in the chapter similar triangles. In this, we have already done one introductory video where we have discussed about what is similarity, what is congruency, what is scale factor, and what are the what type of figures will be always similar. Okay, and also we have discussed the basic proportionality theorem and converse of basic proportionality theorem, also the statements, right now. And in this class, let us solve some problems related to basic proportionality theorem, which are very important, and easily you can score marks by solving those problems. Okay now, so if you are new to my channel, please do subscribe, and if you like my class, please do like and share with your friends, and hit the bell icon for getting notifications of upcoming videos. Okay now, so without wasting any time, let us start our class today. So what is basic proportionality theorem? The basic proportionality theorem states that in a triangle ABC, for example, let us take a triangle like this, A, B, C. If a line is drawn parallel to the third side, such that it meets the other two sides in D and E, such that it meets or it cuts the other two sides in D and E, then we have a conclusion that AD by DB will be equals to AE by EC. So this is very important result. So what is the condition for this to happen here? DE must be parallel to BC. DE must be parallel to BC. So based on this statement, we will be doing many problems. Such an important theorem is this, and you have converse of basic proportionality theorem also, which states reverse. If AD by DB is equals to AE by EC, then we say that it is DE is parallel to BC. That is nothing but converse. Okay, so both are similar actually. Okay, you should understand what is the first condition here. If DE is parallel to BC, if the condition is DE is parallel to BC, then we are talking about basic proportionality theorem. Or if AD by DB is equals to AE by EC, then DE will be parallel to BC. If the condition is about the ratios, then we are talking about converse of basic proportionality theorem. So you keep in mind in that way. If you start with parallel, then that is basic proportionality theorem. If you start with ratio, then that is converse of basic proportionality theorem. Okay, right. Now by using this statement, let us try to solve some problems here. So in this chapter, you should not leave any try this, do this, think and discuss. You should not leave anything now. If you want to score complete marks, and if you want to score 10 out of 10, you should never leave try this, do this in this section. Okay, I hope you will be doing that one. And let us solve some basic problems. Okay, in the following figures, DE is parallel to BC, and here he has given some dimensions, Nana. That is, here he has given 1.5 centimeters. This is 3 centimeters. And if AE is equals to 1 centimeters, find EC. Right now we need to find EC here. So just by looking at the figure, you can say that DE is parallel to BC. So what can you write according to the basic proportionality theorem here? According to basic proportionality theorem, what must be the condition here? AD by DB must be equals to AE by EC. Now here our goal is to find the dimension of EC. Here we need to find EC. So substitute all the values whatever are given here. So AD will be 1.5 and DB is equals to 3 centimeters. You need not write units here. And AE is 1 and EC you need to find. EC you need to find here. So if you simplify, this will be 1.5 ones are 1.5 twos are 1.5 ones are 1.5 twos are. So the numerators are equal, so the denominators must be equal. Therefore you can say that EC is equals to 2 centimeters. So this is the basic problem. This question may be asked in your 1 mark section. So such kind of problems are very important. Okay, most of the students will be scared of similar triangles, but I told you, it is very simple chapter. Just by understanding the logic, you can solve the problem here. In the same way, you have one more problem in your do this, you do that one. Okay, now let me explain some other interesting problems. Here you should not miss even examples are very important here. So see here, Nana, I am explaining you the example 1 here. In a triangle ABC, he is telling that DE is parallel to BC, and he has also given one more condition, that is AD by DB is equals to 3 by 5. AD by DB is equals to 3 by 5. and he has given AC is equals to 5.6 centimeters. AC is equals to 5.6 centimeters, and what we need to find here, AE is equals to how much? You need to find AE, Nana. So this is one of the most important questions which comes under 2 marks. Okay, this question will be coming for you in 2 marks most probably. Why? Because once you observe the dimensions, Nana, what are the dimensions he has given? First of all, so let us go directly with the proof, and I will explain you when we are solving the proof here. Okay, so here when you are solving the problems of similar triangles, you should follow certain format. So first you need to write the given data. So what is the given data here? The given data is that this is DE is parallel to BC. This is one information. DE is parallel to BC here. Okay, and also he has given AD by DB is equals to how much? 3 by 5. Okay, and here we need to see here AC is equals to 5.6 centimeters, and what you need to find here? You need to find AE. Actually this question is not related to proof here, but we need to find EC. We need to find the dimension of EC. None. So if DE is parallel to BC, what is the condition according to basic proportionality theorem? If DE is parallel to BC, we can say that AD by DB must be equals to AE by EC. Clear now? AD, and he has given one more thing, that is AD by DB is equals to 3 by 5 now. AD by DB is equals to how much? 3 by 5. So let us take this one as equation 1, and this is equation 2. From where you got this equation 1? By basic proportionality theorem. By BPT you need to write, and this is the information given. Right now, that is the information given here. After this, what you need to do? So from 1 and 2, what can you write here? From equation 1 and 2, you can write like this: AE by EC is equals to how much? It will be 3 by 5. Clear? I am keeping AE as this, and EC. For EC, I am writing it as, how do I get EC here? From AC, if I subtract AE, from AC, if I subtract AE, I will be getting what? I will be getting EC. Clear? So I am writing here AC minus AE is equals to how much? 3 by 5. Clear? This is very simple. After this, substitute the values. After this, you substitute the values. AC is given as 5.6 here. Just you substitute there. That will be AE by 5.6 minus AE is equals to 3 by 5. AE by 5.6 minus AE is equals to how much? That is 3.5. Do cross multiplication here. If you do cross multiplication, that will be 5AE is equals to 3 into 5.6 minus AE. So this is 5AE is equals to 3 into 5.6 is how much? That is nothing but 16.8 minus 3 into AE is 3AE. Clear? That is 3AE. Now you bring 3AE this side. That is 5AE plus 3AE is equals to 16.8, which is equals to 8AE is equals to 16.8, and from this you can write AE is equals to 16.8 by 8. Nana. So if you simplify this, what you will be getting here? AE is equals to 8 ones are 8 2s are 0.8 ones are. So AE is equals to 2.1 units. Why? Because here he has here he has given centimeters, no? So AE is equals to how much? That is 2.1 centimeters. Problem is very simple, but only the thing is, what are the dimensions given? You need to observe here. Is he giving the parts or he is giving the complete side of a triangle? You should observe that one. Clear now? Here he has given AC. AC means he has given complete side here. In the previous case, we have only the parts. You have AD, you have DB, you have AE, and you have EC. But this is a different problem. That's why here we have mentioned EC as AC minus AE. So here you can write from figure. So this is the very important step in the problem, Nana. Okay, so be careful whenever you are doing such kind of problems. This is very simple problem. It will be getting for you in your 2 marks section. Let us go for the other one. We are discussing about example 2. Why I am explaining the examples also means these are very important. Most of the students, just by looking at the examples, they cannot understand. That's why I am trying to simplify that one, and I am making sure that you will attempt the questions correctly. That's the reason I am explaining examples also for this chapter mainly. Okay, so see here we are talking about example 2, and there is a figure given. So in triangle ABC, he has given that LM is parallel to AB. LM is parallel to AB, and he has given some dimensions also. AL is equals to how much? It is x minus 3. AC is equals to, AC means this complete partner, so AC is given as 2x, so complete AC is equals to how much? 2x here, and BM is given as x minus 2, BM is given as x minus 2, and BC, this complete side BC is given as 2x plus 3 now. So BC is given as 2x plus 3. So whenever you see some dimensions here, try to write them in the figure correctly. If you write them correctly in the figure, then your problem is almost done here. So what is the first condition he has given? So let us solve for x. Here what is our question, and you need to find x here. So in triangle ABC, he has given that LM is parallel to AB now. LM is parallel to AB. So what happens by basic proportionality theorem? By basic proportionality theorem, you can see that CL by LA is equals to CM by MB none. So whenever you are talking about basic proportionality theorem, when you are taking the ratio, start from the vertex here. Okay, so see here nana, CL by LA is equals to CM by MB. Okay, so you need to take the ratios like that. If you take in reverse order also, no problem, but basically you will be taking like that. Right now, if you don't understand the figure, you see from that side. If you see from the other side, then you can easily observe. So if you tilt this one, the figure will be like this now. Your A comes here, B will be here, and C will be on the top, and this will be LM. So how will you take now? So you will be taking like this only now. CL by LA is equals to CM by MB. So you need to observe the figure carefully. Clear? So let us try to solve this one. So by basic proportionality theorem, you will be writing like this. So right here by BPT none, by BPT. So what are the dimensions we have? Let us try to substitute the values there. First of all, CL. Do you have CL? You don't have any CL here, right? CL dimension is not given, but we can get it from, how you can get it? From AC, you subtract AL. From AC, if you subtract AL, you will be getting CL. So I am writing that one only. So this will be AC minus AL by AL, LA or AL, both are correct here. And what is CM here? CM dimension is also not given. So how to write CM here? From BC, if I subtract BM, from BC, if I subtract BM, I'll get CM. So I will be writing like that, BC minus MB by MB none. So here you can write from figure. Clear? Let us now substitute the values. We have each and everything here. AL, what is AL here? That is x minus 3, and AC is 2x. AC is 2x minus, whenever you have minus, you should be very, very careful. And what is AL here? X minus 3. If you write like this, your problem will be gone. So put a bracket for AL here. When you have two terms, better you put a bracket, mainly when you have subtraction symbol here. So this is a small mistake you will be doing, and your marks will be gone. And what is AL here? AL is nothing but x minus 3, which is equals to BC. What is BC here? That is 2x plus 3, and again you have minus, put a bracket, and it will be x minus 2 now. MB is equals to x minus 2 by x minus 2, you write here. Try to simplify the numerators here. Now this will be 2x minus x. If you open the brackets, minus into minus is plus 3 by x minus 3, which is equals to, here also you open the brackets, 2x plus 3 minus x plus 2, minus into minus is plus here by x minus 2 none. Clear? Now you substitute, you try to simplify this one, 2x minus x, that is x plus 3 by x minus 3 will be remain here, and 2x minus x is again x, 3 plus 2 is 5 by x minus 2. What you will be doing here? Just do cross multiplication. If you do cross multiplication, what happens here? This will be x plus 3 into x minus 2, which is equals to x plus 5 into x minus 3 now. Take the denominator to numerator, and here denominator to this side numerator. Okay, then you multiply. How to multiply? X into x, x square, x into minus 2, that is minus 2x. 3 into x, 3x, 3 into minus 2 is minus 6. And again here also the same, x into x is x square, x into minus 3 is minus 3x. 5 into x is plus 5x, and 5 into minus 3 is minus 15. Minus 15 here. Here on the both sides you have x square, you can cancel this one, x square and x square. On the both sides you have 3x also, but you have plus 3x here and minus 3x here, so you should not cancel. Right now, so there you need to simplify. Let us simplify this one. If you simplify this, you will get the answer, that's all. So easy problem. So what do you have here? Minus 2x plus 3x, that will be plus x, that is x minus 6, you will be remaining this side, and here minus 3x plus 5x, that is 2x, 2x minus 15. So this is equals to how much now? 2x minus 15. 2x minus 15. Bring all x to one side and numerical terms to other side. So this will be x minus 2x, and this is minus 15 plus 6 now. So this is minus x is equals to minus 9. Minus 15 plus 6 is minus 9. Be cautious here when you are subtracting or adding integers. So you got x is equals to how much now? X is equals to 9. Here x is not the dimension, here just it is a value. So you will be having no units. Clear? In the example you don't have such kind of analysis, they will be doing all direct steps, Nana. So for your convenience I have done like this. Okay, Nana, see here, this is the example 3 here. The diagonals of a quadrilateral ABCD intersect each other at point O such that AO by BO is equals to CO by DO. Prove that ABCD is a trapezium. So in the starting, in the first part of the question, he has given ABCD is a quadrilateral, and what is our intention? We need to prove that is a trapezium. So for that reason I will be drawing a figure like this. So this is I am taking as ABCD. Okay, ABCD. So in a quadrilateral ABCD, the diagonals are bisected at O, it seems. The diagonals are bisected at O here, and he has given one more condition that AO by BO is equals to CO by DO. AO by BO is equals to CO by DO, and prove that ABCD is a trapezium. So we need to prove that ABCD is a trapezium. So whenever he is asking to prove some quadrilateral as some special quadrilateral, you need to know the properties of that special quadrilateral. Here he is asking us to prove a quadrilateral as trapezium. That means you should know the properties of trapezium here. What is the general property of a trapezium? In a trapezium, in a quadrilateral, if one pair of opposite sides are parallel, then it is a trapezium. So you need to show that one pair is parallel here. That means let us try to show that AB is parallel to DC. That is our intention. We need to show that AB is parallel to DC. If AB is parallel to DC, then the quadrilateral will become a trapezium. For that reason, what we need to do? So I will draw a line like this. I will draw a line. Let us take it as X or L or whatever it is. You take anything. Okay. So such that it meets this point. Let us take the line as L here, and let us take this point as X. In the textbook it is like that only. So let us take as it is in the textbook now, in order to avoid confusion. Then when you are referring also, it will be easy for you. Clear? So draw a line L such that it passes through the point of intersection of diagonals and meets one of the side at X. Clear? So this is the construction part you need to do here. So how to solve this one? So let us go for proof here directly. For that you need to write the given data. What is the given data here? ABCD is quadrilateral, and he has given AO by BO is equals to CO by DO. Right now these are the given information, and we need to prove. What we need to prove here? We need to prove that ABCD is a trapezium. We need to prove that ABCD is a trapezium. For that we have some construction here in the figure. So what is that construction? Draw a line passing through O. Okay, draw a line passing through O such that the line L is parallel to AB now. So let us take the line is parallel to AB here. So you are taking like this now, and meets AD at X run. So here what can you observe? So see here I have taken the line is parallel to AB. I have taken the line L is parallel to AB here. So in this triangle I can apply basic proportionality theorem. In triangle DAB, can I apply basic proportionality theorem or not? Yes. So let us go for proof here. So in the proof, in triangle DAB, I can write here dx by xa is equals to do by OB. Right now, by basic proportionality theorem, the ratios of the sides must be equal. Right now, so for that reason I have taken like this. So this is dx by xa is equals to do by OB here. Clear? And from the figure, what can you say? Already there is one more information for us given, that is, let us take this as equation 1. and here AO by BO, AO by BO is given as CO by DO now, CO by DO, right? So can you find any relation between the equation 1 and the given equation? Can you find any relation? So I want here DO by OB, right? I want here DO by OB. So if I do cross multiplication here, DO comes here and AO comes down, right? So this will be DO by BO is equals to how much now? DO by BO will be equals to CO by AO, CO by AO. So this is very, very important step. Clear? So let us take this as equation 2 now. This equation as 2 here. And from 1 and 2, what you can say here? Here dx by xa is equals to do by ob, and here do by ob is equals to co by ao, co by ao here. So what can you say that dx by xa is equals to how much? Dx by xa is equals to how much? No, that will be equals to co by ao, co by ao. Now xd or ax by xd will be equals to ao by oc, ao by oc now. Right? See here, just I am reciprocating on both the sides. Reciprocating on both the sides. What happens here? Ax by xd is equals to AO by OC. I got it now. So let us apply this to the figure. What happens? Let us see here. So Ax, where is this one? Yes, Ax by xd is equals to AO by OC now. AO by OC. So what can you say that? Here the ratios are equal in a triangle ABC now. The ratios of the sides here are equal here. So what can I say here? This implies I can say that OX is the line which is parallel to OX is the line parallel to CD now. OX is the line parallel to CD. Only if the lines are parallel, then the ratios will be equal. So how you have written this one? I am starting with the ratio and I am coming to the parallel lines. Therefore, this becomes converse of basic proportionality theorem. That will be converse of basic proportionality theorem. So what happens here? In triangle ACD, in triangle ACD, what you have proved now? OX is parallel to CD. OX is parallel to CD. Clear? See here, Nana. L is parallel to AB. From where you got this one? I got this one from construction. Let us take this equation as 3 and this as 4 now. So what happens now? From 3 and 4, you can say that AB is parallel to CD. AB is parallel to CD. Here OX is nothing but you can say that it is L. So AB is parallel to CD. Therefore, what we can say about this one? ABCD is a trapezium. ABCD is a trapezium. Clear? So this is the way you need to prove that a given quadrilateral is a trapezium. Only the thing you should remember more here is about the line. You need to construct that one. So definitely you should remember that whenever you need to prove that it is a trapezium. Nana. So what we have done here, first of all we have drawn a line such that it passes through the point of intersection of the diagonals and it is also parallel to AB. It is also parallel to AB. Now I have taken here, which triangle I have taken first? I have taken this part now. So I have taken the triangle ADB. I have taken the triangle ADB. If I taken in the triangle ADB, these two lines are parallel, means I can apply basic proportionality theorem. For that I got dx by xa is equals to do by ob. Right now, this is the first one I got here. And after that, what happened? In the given equation, I have some information. I have taken that part here. After that, just manipulating. By manipulating something, I got do by ob now. See here, do by ob is equals to co by ao. So I have taken this part as equation 2. From 1 and 2, these two parts are equal. So these two must be equal. So I have written that one. After that, what I did here, I did reciprocating on both the sides. Reciprocating on both the sides. After reciprocating, what happened here now? After reciprocating, what happened here means ax by xd. So you can see like this. Ax by xd is equals to ao by oc now. Ao by oc here. So that we are looking in the other triangle as, let us take now this part. So the triangle is ACD now. The triangle is ACD. In triangle ACD, if the ratios are equal, ax by xd is equals to AO by OC. Ax by xd is equals to AO by OC. So by converse of basic proportionality theorem, what can you say here? So either XO, or you can take the line L also. So XO is parallel to DC here, right? Now XO is parallel to DC, you got it by converse of basic proportionality theorem. So in the starting construction only, you have taken this line is parallel to AB, and now you got this line is parallel to DC. So from both the cases, you can say that AB is parallel to DC. If one pair of opposite sides of a quadrilateral are parallel, then we can say that the quadrilateral is a trapezium. So by using this concept, we have proved this one. So in the last, you can write hence proved. Clear? Let us go for the other example. Let us discuss about example 4, which is also very important. In this problem is just like reverse of the previous case. In trapezium ABCD, he has given already. He has given ABCD as trapezium. In the ABCD is a trapezium where AB is parallel to DC. That means he has mentioned what are the parallel sides there, and also he has given there are 2 points on non-parallel sides, that is E and F. E and F. So there is a point here as E, and there is a point here on F. E and F are the points on the non-parallel sides AD and BC respectively. That means on AD you have E, and on BC you have F. You should carefully draw the figure now. If you draw the figure only, your problem will be correct. And he has given one more condition, that EF, the line EF is parallel to AB. It seems now EF is parallel to AB here. Show that. Then what we need to show here? We need to show that AE by ED, AE by ED, AE by ED is equals to BF by FC. You need to BF by FC. You need to prove none. So for that reason, what we will be doing here means, let us join AC with a diagonal. Let us join AC with a diagonal such that it intersects at some point G. Okay. Now what can you observe here? First of all, let us try to understand what we need to prove here. After that, you can do it. So see here, Nana, AE by ED, AE by ED. So this is nothing but it is the ratio of the parts of a side here. Okay, one side, and you know that this line is parallel to AB, right? Now this line is parallel to AB also, you know that one. And also what do you know here? DC is parallel to AB. If these two lines are parallel and this line is parallel to AB here, automatically this line will be parallel to BC. Understand carefully, Nana. So what I am talking about means, so this is, let us take this as L, this as M, and this as N. You know that these two lines are parallel, right? These two lines are parallel, and also you know that these two lines L and M are parallel. So obviously what happens, if this is parallel to L, this also must be parallel to N, right? M is parallel to L, also it must be parallel to N here. Clear now? So that is the case you will be using here. So be cautious. Right now, so here in this problem we will be saying that EF is parallel to both the sides, and we will be applying basic proportionality theorem for both the triangles here. What are the triangles you will be taking here means, first case you will be taking ADC, and in the other case you need to take CBA. So you should take both the triangles, and from both the triangles you should apply basic proportionality theorem, and you will be getting the results, and by equating those results or from both the results you will be getting the required proof here. Okay, so what we need to do here, let us take ADC triangle. Before that, see here now, solution we need to prove now. So for that, what we have done, so draw AC such that it cuts EF at G. Now draw AC such that it cuts EF at G. So this is the first important point. And what are the informations we got here? So you know that EF is parallel to AB. This is one condition that is given, and also AB is parallel to CD. AB is parallel to CD. This is also the given information. Why? Because AB and CD are the parallel sides of a trapezium here. From both the cases, what you can say here? So you can say that EF is parallel to CD also. EF is parallel to CD. From where you got this one? From 1 and 2. Now from 1 and 2, right? So that means EF is parallel to CD, you have written. Now you take the separate triangles. So let us take some separate triangles, like in triangle ADC. In triangle ADC, I am taking first this part here. I am taking this part here. So already we know that EF is parallel to CD, therefore you can say that EG is parallel to CD or not? Yes. So in triangle ABC, what you can write here, EG is parallel to CD. So from here, what you need to write here, AE by ED is equals to AG by GC. AE by ED will be equals to AG by GC. From where you got this one? By basic proportionality theorem. By basic proportionality theorem. Basic proportionality theorem is also known as Thales theorem. Okay. After this, let us take this as equation 1. Okay, let us take this as equation 1. Then you go for the next triangle. That is in triangle CBA or ABC you can take. In triangle ABC or CBA, what you write here? GF is parallel to AB here. GF is parallel to AB. So from here, what you need to do? By basic proportionality theorem, CF by FB will be equals to CG by GN. Right? Observe carefully. From vertex I am taking here in the triangle ABC. In this triangle, CF by FB must be equals to CG by GA. That is CF by FB is equals to this side, it is CG by GA. So observe here, CF by FB is equals to CG by GA. But if you observe in the first equation, it is AG by GC, but you got here reverse, right? GC is in the denominator, here GC in the numerator, AG in the numerator, GA in the denominator. So just by reciprocating, what we can write here, CF by reciprocate here, if you reciprocate, this will become BF by CF is equals to, what you'll get this side, AG by CG, right? By reciprocating on both sides. By reciprocating on both the sides, you will be getting like this. So let us take this as equation 2. So this is equation 1 and this is equation 2. Observe this one, AG by GC, and this is also AG by GC. So from 1 and 2, both the RHS are equal. So LHS must be equal. Both RHS are equal, therefore LHS must be equal. So you can write here from 1 and 2 equations. From 1 and 2. Sorry, let us take here 3 and 4. Already we have taken 1 and 2, right? So let us take here 3 and 4. From 3 and 4, you can write here AE by ED. Both the RHS are equal, therefore LHS must be equal. AE by ED is equals to BF by FC. BF by CF or FC, both are correct. So what we got here? We got the required proof. Hence, prove you right here. Clear now? So see here what we have done. Already in the question he has given ABCD is a trapezium. That means AB will be parallel to CD, and he has given one more thing, that is E and F are the points on AD and BC such that EF is parallel to AB. So from this information, what we have calculated here, if EF is parallel to AB and AB is parallel to CD, then these both must be parallel. That is the first one we have written here. After this, what we did here, draw AC such that it cuts EF at the point G. Draw AC such that it cuts the EF at the point G. After drawing that line, we have applied basic proportionality theorem for two triangles here. That is ADC is one triangle. So see here, ADC is one triangle, and the next one is ABC. ABC. So the other one is this part. Right. Now we have divided the trapezium into two parts, and for both the triangles we have applied basic proportionality theorem. So this is easy for you. AE by ED will be equals to AG by GC. But in the next one, don't come from the top, go from the bottom only. CF by FB will be equals to CG by GN. CG by GA. So from equation 3 and equation 4, both the RHS are equal, therefore the LHS is equal. Okay. If you have any doubts, you do comment in the comment section. I hope this is understood by you. Okay, now if you are new to my channel, please do subscribe, and if you like my class, please do like and share with your friends, and comment your feedback. If you comment your feedback, then we can change accordingly. Okay, Nana? And don't forget to hit the bell icon for notifications of coming videos. Let us meet in our next class. There will be solving all the exercise problems. Okay, let us meet in that class. Till then, bye.